All right, lesson 12, converting rational numbers to decimals using long division. So now I know that we're using our calculators here, but when our problem is specifically asking us to use long division, we have to show our work using the long division. So let's go over how to do this. So before we talk about that, let's talk about the different kinds of numbers that can be written as decimals. So using our division button, we're going to explore some different quotients, so some different divisions with integers 1 through 11. Record your fractions down below. So what I want you to do right now is just with your calculator, go ahead, take some time, 1 divided by 2, 1 divided by 3, any of the numbers that you can divide that are between 1 and 11, okay? So pause this, try them out, write them down. There's no right or wrong answers, and then unpause it and check your work. Okay, so I'm going to write down just some of the ones I did. So 1/2, 1/3, 4/5, 7/11, 1/10, and 7/9. So those are just some examples that I did. What two types of decimals do we see? Well, I see numbers that don't have the little symbol at the top, which means I see numbers that aren't repeating and numbers that are repeating. So repeating and we call the numbers that don't repeat terminating. Down below, we're going to create a T-chart. So we're going to take those two things, repeating and terminating, and place them at the top of our T-chart. Repeating, terminating. And we're just going to take our examples and list them in the proper section. So our repeating, I had 1/2, 4/5, 1/10. Terminating, I did it backwards on here. I'll just switch them. Okay, repeating, 1/3, 7/11, and 7/9. And then you can add whatever ones you also did to the proper section. Okay, next page. So we're going to see long division with both our terminating and our repeating decimals and how to figure out them. So when we talk about long division, I want us to think about pushing over the fraction. So what I mean by that is I'm going to take this fraction and I'm going to push it over so that it falls. When that happens, the 4 falls before the 3. And that's how I write my long division. Now when I do long division, I'm going to take 4. 4 does not go into 3, so I have to add a decimal. I'm going to add a decimal underneath my division symbol and above it, and add a 0. 4 does go into 30. It goes into 30 7 times, because 7 times 4 is 28. So you're going to write 28 below 30, and you're going to subtract those two. 30 minus 28 leaves us with a 2. I'm going to bring down a 0. 4 does evenly go into 20. It goes into 25 times. This is why it's really important to know your multiplication facts. When we subtract, we have a remainder of 0, so we're all done. Our answer, we got 0.75, but be very careful. There is a negative here. So this tells me my answer is negative 0.75 as a decimal. Okay. Now, with your calculator, you can always double check and make sure that's really the right answer as well. All right, there are 2 problems here for an exercise. I want you to try these ones on your own. Pause the video, give them a try. When you're all set, unpause it and check your work. So I'm going to push this over. 8 and 7. 8 does not go into 7. So I'm going to add a decimal. 8 goes into 70. 8 times 8 is 64. When I subtract them, I have 6 left over, and I'm going to bring a 0 down. 8 goes into 60 7 times, so not evenly. 7 times 8 is 56. Subtract them. I get 4, bring down another 0. 8 does go into 40 evenly. 5 times 8 is 40. When I subtract, I'm left with a remainder of 0. So I'm going to have 0.875. But remember, there is a negative there, so this is negative 0.875. The next one, 16 and 3. Add my decimal, because 16 does not go into 3. 16 does go into 30, but it only goes into 30 once. So 16, I'm going to subtract 30 minus 16. I have 14 left over. 16 does not go into 14, so I'm going to add a 0. Bring it down. Now, if you're not sure how many times 16 goes into 140 in your calculator, just start multiplying things. So 16 times 2, 16 times 3, until you get a number that's just below 140. If I do 16 times 9, it's going to be above that. But 16 times 8 is 128. That's the closest we can get to 140 without going over. When we subtract, we have 12 left over. I'm going to bring down another 0. I'm going to do the same thing. Figure out 16 times what is going to give me the closest to 120. 16 times 7 gives me 112. When I subtract, I am left with 8. I'm going to bring down a 0. 16 does evenly go into 80. It goes into 80 5 times. When I subtract, I don't have a remainder, so I'm all done. So my answer is 0.1875. All right. Those are our terminating or our non-repeating decimals. Let's take a look at our repeating decimals. So we're going to do 1 together. So remember, I'm going to push it over. So 3, then the 1. 3 does not go into 1, so I'm going to add a decimal, add a 0. 3 goes into 10. 3 times 3 is 9. Subtract. 1. That's weird. Add a 0. Bring it down. 10. Well, 3 goes into 10 3 times. 3 times 3 is 9. So what's going to happen is I'm going to keep getting the same remainder every time I go. I'm going to keep having to figure out how many times 3 goes into 10, and I'm going to keep getting the same value. When that happens, that's when I know I have a repeating decimal. And sometimes it's not the first number that repeats. It could be the second or the third. So just make sure you do it a few times to make sure you're seeing the repetition before you just say, oh, I know it should be this. Let's try another one. So I'm going to push over my fraction. 9 is out on the front, 4 on the inside, add a decimal. 9 does not go into 40 evenly, but 9 times 4 is 36. When I subtract them, 40 minus 36 is 4. Let's just verify. Bring down the 0. Same idea, 9 times 4. 4 times 9, 36. 40 minus 36, 4. I'm going to run into the same problem. I can stop there. 0.4 repeating. This is negative. So my answer is negative 0.4 repeating. Let's try the next one. So push it over. 11 on the outside, 1 on the inside, add a 0. What happens here, 11 doesn't even go into 10 either, so I have to add a 0 up top, because that's my placeholder, and add a 0 on the bottom to get 100. 11 goes into 100 99 times. 9 times, because 9 times 11 is 99. When I subtract them, I get 1 left over. But be careful here. I'm going to add a 0, bring it down. 11 does not go into 10, so I have to add another 0 before I can subtract. 11 goes into 100 9 times. 9 times 9 9 times 11 is 99. I still have 1 left over. So what's happening is 0, 9 is repeating. I'm going to have the same 2 steps that keep going on and on. So my repetition, my answer would be negative 0.09 repeating. So be very careful when you notice patterns like that. Keep going a little bit just to make sure that that is true. All right, that is all for this lesson. Good luck on your homework.